Hello everybody and welcome back. Today I'm going to go over your Unit 3 study guide answers with you just so that we are all on the same page and we understand the answers to these different questions. Now before you watch this video, you need to go through and at least read through these questions and ask yourself if you know the answers to the questions. So you need to try to answer them on your own first and then watch this video to help you go back and kind of fill in the gaps where you're missing the information. So you will be able to use this study guide to help you prepare for your Unit 3 test, which is coming up on October 1st. So, don't know why that just popped up. Let's go ahead and get into this really quickly. So we're starting with lesson 1. So I always break your study guides down by the lessons that we did so they flow in the same order in which we learned them. So lesson 1 was rock types, if we're going back to a couple weeks ago when we learned about the different types of rock. So there are 3 different types: igneous, metamorphic, and sedimentary. So remember, igneous rocks form from the cooling of lava and magma. Remember, lava is on top of the Earth's surface and magma is underneath. And an example of igneous rock could be like granite. Now remember, with our igneous rock, there is a difference between intrusive versus extrusive. If it's intrusive, it cools quickly on the Earth's surface and it typically is smooth. And if it's extrusive, it cools slowly underneath the surface and it forms crystals, which is how we get granite. Metamorphic rock forms when rocks are exposed to high heat and pressure, and they can be foliated or non-foliated. So if they're foliated, they have those wavy textures in it, and an example of that would be gneiss. And then of course our sedimentary rock forms when sediments are deposited, compacted, and cemented. And examples of this would be like coquina, which is the bioclastic sedimentary rock. And then just a reminder, sedimentary rock is where you find fossils as well. So question 2 says, what type of rock would you find would you find fossils in, and why? So the answer here would be your sedimentary rock, because the layering of the sediments allows a mold to form around the organism. So the only type of rock where you would find fossils would be sedimentary. Number 3 says, what type of rock would form near a volcano and why? So an igneous rock would form near a volcano because we know to get an igneous rock, we have to have the cooling of magma or lava. So it makes sense that in order to get an igneous rock, we would need to be near a volcano or someplace where volcanic activity is happening. So again, those are our 3 rock types: igneous, metamorphic, and sedimentary. So let's go on to lesson 2, which is the rock cycle. So remember, we have to just be able to look at these images and follow the arrows and understand which process goes with which rock type. So if we look at number 4, it says in figure 3.1, what type of rock should occur in the part of the rock cycle labeled B? So if we go to B, if we look at B right here, it's going to be a rock type. So if we start at the top, we've got magma, and your personal example in your notebook is the magma is at the bottom. It doesn't matter where it is as long as the activities are the same and the rocks are the same. So we have our magma here. So we're starting with magma, and magma is going through the process of cooling. So if magma is cooling, that means we're going to get igneous rock. So the answer to this question would be igneous rock, because igneous rock is formed from the cooling of magma. Question 5 says in figure 3.1, what processes could be occurring in the part of the rock cycle labeled E? So let's go back and look at E. So let's find it on here. E is at the very bottom. Okay. So we have magma that's cooled into igneous rock, and then igneous rock is weathered and eroded to get sediments. And our sediments are something's going to have to happen to these sediments to form the rock that goes right here. Well, we know that sediments will form sedimentary rock, right? But what is the process that sediments have to go through to get to sedimentary rock? Well, the answer here is going to be that compaction and cementation, okay? So rocks are weathered down, And as they get layered on top of each other, they are compacted, which just means they're subjected to pressure. And then they will be cemented into one large rock. So compaction and cementation of these sediments has to occur in order to get our sedimentary rock, which would be located in F. And then finally 6 says, what type of rock should occur in the part of the rock cycle labeled F? Well, we just talked about that the cooling of the igneous rock, the weathering and the erosion of the igneous rock led to pieces of sediment. The sediment was cemented and compacted into F, which would be our sedimentary rock. So the answer there is sedimentary rock. Okay. Moving on to lesson 3, the barrier islands. So when we talked about barrier islands, we specifically talked about the NC Outer Banks, and we watched that video on Shelly Island, if you guys remember, and we talked about that a little bit. So longshore currents are one of the types of currents that will help contribute to the movement of sand to form barrier islands, and longshore currents actually run parallel to the shore. So they run beside the shore in a parallel manner. So 8 says true or false. It is a good idea to build houses on barrier islands. Explain your answer. So you should have answered false here. So it is not a good idea to build houses on barrier islands because the barrier islands are made of sand, and because of the currents and hurricanes that come through, those barrier islands can be molded and shaped and changed very quickly. So you don't want to build a house and then have it fall down because the sand is shifting. Question 9 says list the 2 main reasons that barrier islands are important. So 1, they act as a buffer against storms for the mainland, and they provide important habitats for organisms. So they act as a buffer and they provide important habitats. Lesson 4 was soil. So 10 says the soil horizon that contains leaf litter, organic matter, and may or may not be present is the O horizon. So if you remember on your soil horizons, O is the one on the very top. Sometimes there are not O horizons because it really is just kind of the top layer that sits on top of like the soil and the grass. So now as it's getting closer to fall, we're going to have these leaves dying and falling off the trees. We're going to see more O horizons in our own area. So for 11, we're going to use the soil texture triangle in order to answer this question. And I'm going to go ahead and do this on here just to show you as a review on how to do it. So in the figure 5.1, use the figure 5-1 to determine what a soil is called if it has 20% clay, 60% silt, and 20% sand. So let's take a look. Remember, we're going to start with our clay. So I'm going to grab a line here. Oops. It took me down. I didn't want to do that. So we're going to start with clay. We've got 20% clay. So we're going to look on the left-hand side here. And we're going to start with our 20%. So clay is on the left, and the numbers correspond to the percentage of that particle in the soil. So this soil sample, if we were to separate it all out, would be composed of 20% clay. So I'm going to go ahead and put my dot here. That's not what I wanted to do. I might just have to use a drawing. Let's see if I can do that. Maybe not. Maybe I'll just have to do it the old-fashioned way and show you with my cursor. So anyway, we start with 20% clay. So we will put our cursor here and we would follow the line over from 20%. So we're just going to have to keep it in our mind where our 20% clay is. So clay goes from left to right, so we would draw our picture from left to right. And you guys still have your soil texture triangle assignment in Google Slides. You could always pull that up and use that if you needed to. And then we are 60% silt, so we're going to come to our percentage silt over here. We're going to find 60%. We're going to put our cursor there, and we're going to follow our cursor down. So remember, we're trying to find where these 3 lines intersect. So we had 20% clay, and we had 60% silt. So right now they're coming together right here, but we have to find our final component, which is sand. Sand is the largest particle, And this particular one is 20% sand. So sand is on the bottom. Here's that 20% sand, and we would follow that up at an angle. So the place where the 20% clay, the 60% silt, and the 20% sand intersect should be silty loam. And silty loam would be the classification of our soil texture. 12 says, what are the proportions of clay, silt, and sand shown at point C? So if we go to point C on our little soil texture triangle right here, we just have to follow the lines to the correct percentage of clay, silt, and sand. So here's C. So if we follow over to the clay side, we get 10% clay. Okay, and literally you just follow it over from the point. So we've got 10% clay. If we follow the silt line, we should find that there's 20% silt. And then if we follow the sand side, it's 70%. So we've got 10 clay, 20 silt, and 70 sand. So 10% clay, 20% silt, and 70% sand. So moving on to lesson 5, which was weathering. And I think here is where I will finish this video and then start another one to finish off our study guide. So weathering was our lesson on our chemical versus our physical weathering. So there are just a few examples here, and we need to decide whether they are chemical or physical. So 13 says, water gets into cracks in a rock and freezes. As the ice expands, the rock breaks apart. This is physical weathering. And if you guys remember from that lesson, it was an independent lesson, but I explained to you in that presentation that it was something called frost wedging. And so that's when water gets into the cracks of rocks. And obviously if it's sub-zero temperature, or not sub-zero, but sub-freezing temperature, so below 32 Fahrenheit, the water will freeze. And as it freezes, it will expand and it will push the cracks in the rocks further apart, and it will weather them. So physical weathering is just the breakdown of the rock without any change to the chemical composition. 14 says, water in a cave reacts with limestone and causes it to dissolve. This is an example of chemical weathering. So the reaction of the limestone with the water and the dissolution of the rock itself. So as the rock is dissolving, it's breaking down. That's the weathering part. But it's also being changed on a chemical level because the limestone, the minerals in the limestone are reacting with the water. So this is chemical weathering. And then 15 says, you kick a rock as you walk down the street and it breaks apart on the sidewalk. This is going to be physical weathering because we're not changing the rock on a chemical level. It's just being broken down by force. Okay, so if it's broken down by force, if the rock is just breaking apart, it is physical weathering. If there's some kind of chemical reaction going on with carbon dioxide, water, if something's being dissolved, that's going to be an example of chemical weathering. Okay, I'm going to stop this video here and I'm going to pick up with another one for the remainder of our study guide.